Hej alle sammen, og velkommen til vores webinar i dag omkring API's 9D Later. Mit navn er Jakob, jeg er direktør her hos Kræver, og jeg vil være jeres vært i dag. Vi har et spændende program, vi skal igennem. Først så vil jeg lige lave en kort indflyvning til Kræver og hvem vi er. Og så får I en præsentation af det her udstyr, vi skal have demonstreret. Og det bliver demonstreret af API's General Manager for EMEA, altså Europa, Jan Lot. Jan har også kørt en live demonstration her fra vores værksted i Koldby, direkte fra kontoret i Heidelberg. Og det ligger nede omkring Stuttgart, til dem der ikke ved det. Og til sidst der vil vi lave en Q&A session, hvor I har mulighed for at stille alle jeres spørgsmål, I må have omkring det. Det er vist derude i højre side på YouTube. Så giv den bare gas med spørgsmål. Her den sidste uge, der har vi rejst rundt med det her udstyr i Aalborg og lidt nede i Midtjylland og i Esbjerg. Og det har været rigtig, rigtig spændende at prøve af på nogle store emner og også komplicerede emner, og vi er blevet taget rigtig godt imod. Og det er jo så det udstyr, I får lov til at opleve i dag. Det er den her, der står lige her ved siden af mig. Lige en kort præsentation af vores virksomhed, Kræver, og hvad det er, vi står for. Til jer, der ikke ved det, så er vi jo en 3D-specialiseret virksomhed, som ikke laver enten at lave 3D-opmåling. Vi har været stolte forhandlere af 3D-scanningsudstyr fra kræverform i over 10 år, og de sidste 3 år, der har vi også været forhandlere af blandt andet lasertracker og nu den nye 9D Ladar fra API. Og vores mission, det er simpelthen at vise, hvad 3D-opmåling det kan, og hvilken forskel det kan gøre i industrien. Lige fra præcision til effektivitet. Vi arbejder altid med en ærlig og en jordnær tilgang til opgaverne, og vi er her for at støtte jer hele vejen. Men nu til det, som det hele det handler om, og dagens hovedtaler, and now I think I'll go into English, because now we have to say hi to Jan. Hi Jan, how are you doing?
Hi. I'm fine.
We are very pleased to have you here on this online connection to Heidelberg. Jan is the general manager of API in Europe, EMEA it's called, and he will guide us through this presentation of the 9D Ladar. He will also do a demonstration on how the equipment works, remotely controlled directly from Heidelberg in Germany. So just sit back and enjoy the session. Take it away, Jan.
Okay, yeah, thanks Jakob for the introduction. Let me just share my screen so we can go into the presentation mode. Hopefully you can see it. I think should be okay. Okay, yeah. Okay, excellent. Yeah, this week we had a quite exciting week with Kræver. My colleagues were joining the Kræver team for some customer visits, mainly in the wind energy and shipyard business. And I guess we could visit more or less all huge plants in Denmark, especially for the wind energy, and show the benefits of the 9D Ladar, particular to their applications. For today, I just want to give a little bit overview about who is API. So I'm not sure if everybody is well informed and well aware of API in general. Actually, our founder and owner of the company, Dr. Cam Lau, was the inventor of the laser tracker technology back in the end of the 80s. And from there, API was always developing laser-based measurement systems for different applications. It starts from the laser tracker into machine tool calibration, and finally, 2 years ago, we came up with the latest generation or the latest innovation of laser-based systems, the so-called 9D Ladar. API is, we always said, global local. Jakob mentioned I'm here from Heidelberg. That's the European head office of API. We have our brands and offices worldwide. So we have our headquarters in US. We have facilities in China, India, and as well as South America, Brazil. So we are always on their side to serve the customers. Here in Europe, we have a couple of partners like Quaborg, which serving the regions and can provide our products, our solutions, as well as services with our products to you to help you and solve your measurement tasks. But looking a little bit more into details, today we focus on the 9D LADAR, which is a solution for automation. The 9D LADAR is a contactless scanning device, and that's perfectly made for automated and automated guided measurement applications. We have a couple of other instruments as well. Maybe just to name some of them, and already said about the laser tracker and the accessories. We can always combine it and make a perfect solution for our customers. Using 60 tracking devices with a tracker and a vPro or the STS can help to relocate sensors in a larger volume of workspace. And at the end, if it belongs or comes to an automated guided measurement, sometimes robots are needed or rails are needed, and also these rails and robots can be calibrated or verified with our equipment. So we call it integrated metrology or smart factory inspection systems. That means we want to solve the quite complex measurement tasks of our customers. And this can be done by a standalone system or up to a completely automated cell. I will show you some animations later on. Unfortunately, I can only show animations as most of our customers are not really happy to share their high performant solutions developed together with API. Yeah, but I think we can also look at presentations and check specification, but I guess to get a good idea about what does the dynamic 9D LADAR can do, I would just show you some videos, and please enjoy it. And afterwards, as Jakob said as well, we will have a Q&A session. If you have questions in between, just send it or chat it, and we can follow up later on.
API's Dynamic 9D LADAR presents a breakthrough technology set to revolutionize automated production measurement. 9D LADAR introduces the first interferometri-based industrial measurement system in the world. 9D LADAR's high-speed, contactless measurements deliver accurate data collection in real time for part measurement, feature inspection, point cloud processing, reverse engineering, and more. The system is more than 100 times more sensitive than phase detection techniques. Dynamic 9D LADAR features an onboard scale reference system that delivers both 2D and 3D accuracies unparalleled by laser radar, and is the fastest system available, sampling 20,000 points per second with high-density raster scanning control up to 50 lines per second at 0.1 millimeter horizontal line resolution. 9D LADAR's micron-level accuracy can be applied regardless of surface reflectivity, material, finish, or incident angle. The Smart iVision 8-megapixel camera system assists with part recognition, allowing for programmable automated feature measurement and GD&T, revealing probe-level feature clarity of holes and other geometric details. 9D LADAR is ready to measure 15 minutes after setup, eliminates external controllers with an embedded state-of-the-art controller and signal processor, weighs less than 11 kilograms, and has a 17 by 10-inch footprint that can be mounted to a robot, rail, or gantry CMM for automated measurements.
Yeah, I think this gives you a rough idea about what can the system be, what's about the system itself, some specification. You see it as compact, lightweight system, easy to bring to your applications. But at the end, how it can look like, and I think a good and a strong business in Denmark is mainly related to wind energy. And this animation just gives you some idea how it can look like. So we have seen you can open a window, you select points or features, but at the end, going to the next step, you will see we can combine it with a rail or a robot to also extend the full range of a LADAR. So the LADAR can measure up to 25 meters in a radius, so 50 meters in a diameter. But for long blades or molds, which are meanwhile 80 to 100 meters long, we need to relocate the system. You see also here we have a 6D device to relocate, use the tracker to stitch all the scans together. Or as another example, it's about the flange measurement, where you have really dedicated points in a high position. You need to have a cherry picker or a forklifter to reach these points. From a safety perspective, it's complicated. And if you just have a system, put it on the floor on a tripod and scan the complete flange, it helps you to save a lot of time and money and reduce safety risks. So you see, it's like a big combination of different aspects to be considered, and which can help in particular solutions. Another and more advanced application is if you can even combine it with a fully automated guided vehicle, HEV, and this can help you to really autonomously guide or do measurements from the jig inspection. As you can see here, we have the LADAR on an HEV. The HEV moves to the right position. He knows roughly the position. We are using some tooling balls to realign and fine adjust the position. And from this position, maybe combined with a vertical lift, you can reach more or less all the points to really fully automate or fully automated measure your jigs and features. So in this case, if you have the first position done, it moves automatically to the second one, relocate again. This relocation could be also done with a tracker instead of using the tooling balls, which are predefined, but it depends a little bit on the time requirement. And you see we can measure single points or surface points or features to control the complete jig. Afterwards, you bring in the part you want to inspect, and so we can combine the jig inspection as well as the part inspection in one single setup. So it's just a matter of how we can optimize and automate the complete process. It's a matter of what are the measurement tasks, but especially over the last year, 2 years, we are really in close contact with aerospace, wind energy companies, automotive companies, bringing up their measurement applications and requirements, and really explain us what is their challenge, and we try to optimize it. So it could be a surface scan and feature scan, as I said, and this combination helps a lot to really fully automate it, the measurements in accuracy, which is a few tenths of a millimeter or hundreds of a millimeter only. So this said, I would say it's a quite interesting approach. And from the let's say from the presentation mode, I would go over into a little bit more practical part and show you on a really quick and easy example how it works and how it can look like for your application. I think everybody has some applications in his mind, but at the end, to show how it works, it's in the most cases the most important. Here we can just see some nice pictures from a job where we had to scan helicopters, and also here we use, as it's seen in the animation, an automatic driven robot who is moving around and who allows us to get all the measurements done fully automated. Yeah, this said, why use API solution for automations? We have a large portfolio of products. We can really complete complex production tasks or measurement tasks. And the benefit for you is you can increase your production and decrease your costs. And at the end, custom automated metrology solutions will be the part of the future. And we from API and also from kræver for sure are looking forward to support you and we have already a lot of satisfied customers, and maybe you can add you, or maybe you are already here on our list, and it's interesting to you to add some further API equipment in your location. This said, I'm done with my presentation, and I will stop sharing my screen, as I understood. Jacob?
So Jan, just turn this down to avoid the echo.
So I'm still visible.
Here in our shop, we have actually a flange. It's right there on the on the edge here, and I was wondering if you think it could be possible.
Good.
On we have like 6.5 meters here. If it could be possible
to flange.
To scan
with the different holes.
The diameters.
So typically, let's say that's a part of the windmill or wind turbine. And what is interesting to get all these flange measured, and we are using right now, that's the Measure Pro software API. It's a simple tool to do some scans and some easy geometric control. The LADAR is also implemented in other software packages like Polyworks, SA, and Metrolog, for example. But for sure, depending on your needs, we will figure out what is the right software solution for you and find the best. So what I did here, we have a cut model. I already prepared in a way that we can align us to this cut. For sure, a flange like this is always a little bit challenging as it is quite symmetric. Therefore, I selected 3 holes for the alignment. And as you have seen maybe in the video, we have this on-site video, so you can navigate here in the live video screen and put the laser beam in on the right position. So we see this one is 3.4 meters roughly from the LADAR position, and we can select a right angle or a polygon or a single points to do to define our scan. So what we can do in the beginning, we can do a rough scan and say we would like to have 2.5 millimeter, or maybe if we say 3 millimeter is also sufficient. We can decrease the time. You see each millimeter of line spacing will automatically decrease the timing. So let's say find a good average between scanning and accuracy. And that's all we can do here. If you go back to the Measure Pro software, we will see that there is automatically a scan pass. I will zoom a little bit inside. That's a pass the laser beam will move. And if I press scan once, you will see that the laser beam will moving up and down, or it would be also possible to do it on a vertical position and scan the surface of the ring. So and with the point cloud generated, I will hide this one. Still moving, as you can see here. Okay, here we go. So you see we have a full scan yet of the ring. There's a little bit of the background, which is the wall. And maybe also one of the advantages of the LADAR, 9D LADAR, what does it mean? I guess everybody is aware of XD, XYZ as a 3D coordinates, IJK as orientation, but at the end, the API system offers you the colorization as well. The black ring is for sure not as impressive as a colored part, but you can see the background, the gray background is visible, and it helps you dramatically to orient yourself in larger scans. So what you can do yet is we have this scan, we can do some extractions out of the point cloud. It's a quite easy one. Depending on the scan itself, you might have a small plane. Just to say, I would like to have on this area a projection plane, and this plane I would like to use for a circle, which is minimum best fit or maximum fitting. This plane should be my constraint. Should be this one, I guess. And then we can select. Oh, hold on. Now I did a small bit. No. Let's take this one. Now I'm mixed up. Okay. Did I got the plane? No. I think we need to construct the plane again. So we take the plane here and say fit. So we have a small plane as a projection plane, and then we can use the cylinder as the circle, and as minimum project it down into this plane, and we just select with a brush the area we want to fit the circle, which is roughly here. Let's say a little bit bigger, okay. And then we say fit, and we see it is fitting automatically this circle. Oh, this is the old one from previously. And that's the way how we can go ahead. And, oh, sorry. Okay. We can go ahead and fit our features we need to do. So I prepared this one already in advance, and using those circles fitted here to the point cloud, we can also use them for the data alignment. Say want to do it by features, and then you select the nominals, you select the measured one. We fit the whole stuff. We will get our standard deviation. We can apply it, and you will see that the cut model and the point cloud. Cut model needs to be. Oops. Let's take this one. No. Here. Oh. So the cut model and the point cloud are located to each other. What we could do yet is we can say we would like to have a color map for the complete surface. It will be a color map, and we may just take red, get rid of. Hold on. That's remote control. Sometimes it's not as fast as I wish. Okay, let's see. Okay, so you see the deviations, some impacts here in a range of some tens of millimeter. I think it's 3D printed flange, if I'm right. So you can get easily a good overview about what needs to be done. More interesting might be, let's hide all these. We can also extract again from the cut model. So we can extract, auto-extract all the circles, or we do extract circles manually. And for example, I would like to measure this one. Hold on. Is it already done? Yeah. So right now we found a lot of different circles automatically extracted, but this will take too much time if we scan all of them. So let me just delete this one, and we do it in a smaller way. So what we can say, for example, I would like to show all the extractable features, and we want to select maybe just some circles, and I would like to measure these circles here. Maybe let's say that's all. And press OK. So we create the normals out of the cat. And now we can generate a scan path for those smaller circles. And what happens yet, he will automatically create a small, more density scan for each single hole and do the whole scanning step by step. So if you are aligned, you can select from the CAD model your features. The software typically automatically calculate the scan path required and do the scanning. So we have selected 5 circles, and it took us maybe just a few seconds to get all this stuff measured. So that's it. If I hide our scan paths, you see we have this point clouds now located here, and we have also all these circles measured. And now we can even extract from the hold on. What happens yet? Okay, we can
I ask you a
extract
question, Jan?
the normals, and oh, I need to select the right point clouds.
I have a question, Jan.
Okay.
Yes. If you want to do this, you have several items, do you need to do all of this every time, or can it be like automated process?
No, actually, you do it once, and you can do a kind of macro or program to repeat all this stuff.
So that means that if you have made a program, then you can just have anybody actually set it up and do the measurement.
Yeah, exactly. So at the end, if you prepare the program in the right way, you have predefined scan paths, and then you can go and say, I would like to scan all of them. And he will automatically do the full scan of the surface and do the detailed scans of the surface as well. And at the end, you can get a couple of annotations, which gives you the value, the nominal values, and the deviations, for example, for those single items.
So that means that if you were at a big flange, you will be able to take pretty fast, like 24 holes, and have BCD measurements on 12 BCD measurements pretty fast on a big flange without touching it.
Yeah, exactly. So if you want to do it quickly, rough scan to align, and then the detailed scan for the area. And if it is prepared once, you just need to have the first alignment and then or the rough position of your reference points or reference features and do it fully automatic. I think, Søren, you might remember the time we played the first time. So we could do this flange measurement within a few seconds. And our demonstration on one customer side, you could do a, was it 5-meter flange, the full scan in 15 minutes. And after 15 minutes, you have the automatic analysis.
Yeah, it's pretty nice. I think it's really something that can make a lot of changes especially in the turbine industry.
Yeah.
That you don't have to go in a cherry picker and have a guy up there, putting in risk of falling out or, touching the surface in general.
Exactly. Yeah, I think I don't want to do too much details yet, and we are maybe a little bit in our time frame.
Yeah.
So in this
I'll let you finish up.
I would hand over back to Jakob or Søren to continue.
Yes, thank you, Jan. This was very inspiring. I've seen it live on bigger flanges than this one, and it's even more impressive. So I'll go over in Danish for a short moment of time. Jeg håber, I har nydt præsentationen. Hvis der er sådan, der er nogle spørgsmål, så skriv dem endelig her i feltet, så vi kan nå at få dem med. Det ser ikke umiddelbart ud til, at det er tilfældet. Vi har egentlig sat os for, at det skulle tage en halv times tid det her, og det er den tid, vi netop lige har overskredet lige nu. So once again, Jan, thank you so much for this presentation. And I wish you a nice weekend, nice work day, and then weekend. Og til alle jer, der har set med, vi sender det her ud til jer, så I kan se det bagefter igen og dele det med kolleger og hvem I ellers kunne tænke at gøre det med. Herfra der er der vist kun at sige tak for nu og rigtig god weekend.